This video is page 3 of the Unit 1 summative review for Math 3. Problem number 11, analyze the graph. Which function could model the graph? Select all that apply. What I want to do is focus on just the equations first and look for their key features and then see if I can match them up to the possible graph. Part A is written in vertex form. I know that this is concave up, and the vertex is -2, 1. I'm going to mark that as vertex. Part B is in factored form. So part B is concave down. The leading value here is negative, so that's concave down. And the x-intercepts are 4, 0, and 3, 0. Part C is in vertex form again. This is concave down, and the vertex is the point. There's an x in vertex, -4, 2. And part D is also in factored form. This is concave down. All right, and the factors will become x-intercepts. And so the two x-intercepts are -2, 0 and -3, 0. All right, so I want to compare these key features to the graph. So the first thing I notice is this graph is concave down. So immediately I can throw out part A. It doesn't even matter if the vertex matches or doesn't. All right. Now I'm going to zoom out a little bit so I can actually see the full graph. So clearly these x-intercepts would both have to be negative because we're to the left of the origin. So these two don't make any sense. So let's go ahead and throw out part B. All right, so concave down and the vertex is -4, 2. So if I start at the origin, I could say that this is -4, +2. So yeah, part C could be a possible solution. And then part D is concave down with x-intercepts of -2, 0 and -3, 0. Could this be -2 and that be -3? Sure could. This is good. This is another possible answer. So for problem 11, both part C and part D could possibly model that graph. All right, number 12 is really specific. It says which of these graphs actually represents this function. So I'm going to do the same thing I've been doing and look at my key features. This is in vertex form. So because of this negative, we are concave down, and the actual vertex point is the point 3, -2. Okay? So when I look at my four options here, A and C I can immediately throw out because they're concave up, and that doesn't match our equation. Part B, let's see what we've got. We have a vertex of 3, -2. So 3, -2. So this point right here is 100% the vertex. That's my answer. I want to take a quick look at part D just to make sure it's also not an answer. Let's see. I could go to 3, but then this is +2 for the vertex. That doesn't match what we had. So only part B is a possible answer. Okay. Question number 13 is all about evaluating functions. Now, 3 functions are defined for you. K of x is equal to 6x. M of x is equal to 12 plus 2x squared. And P of x is equal to the absolute value of 5x. So the first thing you want to do is when you look at something like part A is make sure you're pulling from the right function. So part A is the P function. So I definitely want to use this piece. And wherever I have an x, I am going to replace it with a -4 in this case. And then all I have to do is simplify that expression. So 5 times -4 is -20. The absolute value of -20 is +20. So P of -4 equals 20. So that's the last part for part A. Let's see, part B, we're using the M function, and everywhere we have an x, we're going to replace it with a -3. So order of operations tells me I need to do my exponents before I do multiplication or addition. -3 squared is 9. So then I'm going to do multiplication. So we've got 2 times 9 is 18. And then 12 plus 18 is 30. So m of negative 3 is equal to 30. All right, so now when you have something like part C where it's 2 different functions and then you have to do something with it, oftentimes what helps is just to do each function on its own. So the first thing I'm going to do here is k of 1. And k of 1 is pulling from the k function here, which is 6x. So everywhere I have an x, I'm going to replace it with a 1. So that's just 6. Separately, I'm going to figure out p of 3. So my p function is the absolute value of 5x. So the absolute value of 5 times, in this case, 3. Let's make an absolute value bar there. All right, so the absolute value of 15 is just 15. And then if I could look at this, right, this problem said you were supposed to take k of 1 plus p of 3. Well, k of 1 is 6 plus p of 3 is 15. That's 21. All right, so when you have those functions that have, or problems that have multiple functions called, just separate it into 2 separate little problems and do it that way. All right, part D, let me slide over just a little bit so I have some space here. So part D, I'm going to figure out the m of 4 function first. So this is 12 plus 2 times 4 squared. All right, order of operations, I have to do my power first. So let's see, 2 times 16 is 32, and then 12 plus 32 would be 44. All right. Now, the function tells me, or this problem tells me I'm supposed to take 2 times m of 4. So 2 times 44, well, that equals 88. All right. So part D is done. Let's go ahead and slide on over to, apparently these are lettered out of order. We have another part B. Let's see, k of negative 3 minus m of negative 1. So I'm going to break it up into 2 pieces. So I'm going to do k of negative 3 first. So that's 6 times negative, I don't know what I'm writing here, so let's try that again. 6 times negative 3, so that's negative 18. Separately, I'm going to figure out m of negative 1, so that's 12 plus 2 times negative 1 squared. Need to be careful. I'm actually going to slide this over, so just give me 1 second. We'll keep the color coding going. So let's see, 12 plus 2 times 1, so 12 plus 2, so this is going to equal 14. All right, so now the problem originally said k of negative 3 minus m of negative 1. Well, k of negative 3 is negative 18, and then we're going to subtract 14 from that. So let's see what that gets us. That would be negative 32. Okay. All right, if we keep moving on. Now, f in this case, hold on, whoops, losing my mind here. All right. So this expression right here has 3 different function calls. So be careful that you make sure you do all 3 of them. So let's see, if we do p of negative 2 first, this is the absolute value of 5 times negative 2. So that's going to be the absolute value of negative 10, which is just 10. All right, so that one's done. Now, separately, I'm going to do k of 5. Well, k of 5 is just 6 times 5. Well, that's 30. And I'm going to run out of room if I keep going to the right here, so I'll just put m of negative 3 down below. Now, if you recognize this one, we actually already solved it right here. So if you have it, it hasn't changed, right? The function's still the same function, it's still the same value. So just go ahead and kind of steal this answer. Totally fine. So then if we look at the function, we've got p of negative 2 plus k of 5 minus m of negative 3. Well, p of negative 2 is 10, plus k of 5 is 30, minus m of negative 3 is 30. So 10 plus 30 minus 30 is just 10. Okay, we've got one more to go here for part G. So again, 2 separate little problems. I'm going to do m of 0. So this is 12 plus 2 times 0 squared. This would be 12 plus 2 times 0, which is just 12. Because 2 times 0 is 0, and adding 0 to 12 isn't going to change anything. Let's see. Then separately, I want to make sure I'm using the right k function. So that was 6x. So k of 2 is equal to 6x. So that would be 6 times 2. So that's 12. So our function, right, our problem here says we're going to take m of 0 divided by k of 2. Well, m of 0 is 12 divided by k of 2. That looks like a horrible division sign. Hold on a second. Let's try that again. Divided by k of 2 is 12. So 12 divided by 12 is just 1. Okay? All right, so that takes us to the end of page 3. There will be a separate video for page 4. Let me know if you have any questions or concerns.